Okay, what if I told you that for the last 100 years or so, we've been looking at the brain all wrong? That it's not just some wet, messy classical computer, but a quantum machine of incredible sophistication. Today, we're diving into a really radical new blueprint for consciousness, and it suggests that biology isn't just a passive victim of physics, but an active architect of its very own quantum reality. So let's explore this blueprint, starting with the massive paradox it's trying to solve.
So here's the game plan. We'll start with the central paradox that has really stumped scientists. Then, we'll get into the blueprint itself, what this quantum system is actually trying to build. After that, we'll deconstruct nature's toolkit, the biological machinery that makes it all tick. Then we'll see how all these parts come together in this incredible symphony. And finally, the best part, we'll look at the testable predictions that could actually prove this whole thing right.
All right, first up, we have to tackle the big one, the central challenge, the, quote, impossible problem that has kept scientists up at night for decades, the quantum brain paradox.
And this really gets to the heart of the problem. You see, quantum effects are notoriously fragile. They usually need temperatures near absolute zero, total isolation. So how on earth could they survive inside a warm, wet, frankly chaotic environment like the human brain, which is sitting at 300 Kelvin? Classical physics says, no way. The thermal noise should just obliterate them instantly. But this model? It proposes something totally different, that biology has evolved to be an active quantum engineering project, designed specifically to protect these delicate quantum states. Okay, so if biology is this grand engineering project, what's it building? What's the point? Well, that brings us to Section 2, the blueprint for a self. This is the architect's ultimate goal. The blueprint is actually pretty straightforward. It's got two parts. The goal? To solve what philosophers call the binding problem. How do all the separate bits of information, what you see, what you hear, what you think, bind together into one single unified moment of now? The answer proposed here is a unified quantum state. The self is basically a single, indivisible quantum system where everything is perfectly in sync. And the rule? This is where it gets really wild. The model suggests that it's not random noise that collapses this quantum state. It's gravity. Yeah, gravity itself. This Penrose limit acts like a fundamental cosmic clock, ticking off discrete moments of our experience. So biology's whole job is just to keep this quantum state alive long enough for gravity to do its thing.
So how in the world does biology pull this off? Let's jump into Section 3 and deconstruct the machine. We're going to look at 4 distinct layers of defense that make up nature's quantum toolkit.
Okay, layer 1 is what we can call the quantum Faraday cage. You have to forget thinking about the inside of a cell is just a bag of water. It's not. The skeleton, with its complex fractal geometry, creates these special exclusion zones. And this is the first line of defense. These zones basically freeze the local electromagnetic vacuum, and what that does is dramatically reduce the thermal noise that could mess with a quantum state. It's kind of like building tiny soundproof rooms for quantum computation right inside our own cells.
Next up, layer 2, the frictionless superhighway. Now, classically, you'd think of electrons moving through our body like cars in rush hour traffic, bumping around, generating heat, creating friction. But it turns out the natural handedness or chirality of our molecules enables this amazing quantum phenomenon called chirality-induced spin selectivity, or CISS. This basically locks an electron's spin to its momentum, creating a perfect frictionless express lane. Energy can just travel ballistically with no heat loss. This is crucial because it stops the whole system from literally cooking itself from the inside out. Now for layer 3, the orchestra of light. Deep inside our neurons, we have these things called microtubules, and they are packed with light-sensitive molecules. But here's the thing, they don't act alone. They all synchronize. It's a process called Dix superradiance. Think of it like this. One person singing in a huge stadium, easy to drown out. But a choir of thousands, all singing the exact same note, perfectly in unison, that is powerful. It's robust. That's what these molecules do. They work together to form one giant, macroscopic quantum bit that's incredibly resistant to noise. And the final layer is the active support system, the power and the pulse. To make this whole orchestra work, you need 2 things, a conductor and a ton of energy. Well, the pulse of our own heartbeat sends this pressure wave through the brain, acting like a metronome, a synchronizing clock for the whole performance. And the power? The brain's metabolism provides way more energy than is needed to maintain this quantum state. The key takeaway here is that biology isn't just squeaking by, it's thermodynamically overpowered for this job. It's got more than enough juice.
Okay, so we've seen all the individual instruments. Now it's time for Section 4, the Symphony of Synergy. This is the real aha moment,
where we see how all these pieces come together to do what seems impossible.
This is where it all clicks. Each of those layers provides a massive reduction in noise. That dielectric shielding gives us a 20 times reduction, the spin protection another 100 times, and the collective enhancement from that orchestra of light a staggering 10,000 times reduction. So when you multiply all those factors together, the effective temperature that the quantum system actually experiences just plummets. It goes from 300 Kelvin, body temperature, all the way down to the millikelvin range. That is effectively colder than deep space, and at that temperature, gravity finally overpowers the thermal noise. The system reaches the Penrose limit. The clock ticks.
So, why go through all this trouble? What's the payoff? Well, this quantum model offers way better explanations for things that classical biology just really struggles with. Like, how does the brain bind all this information together instantly across different regions? Not with slow chemical signals, but with non-local quantum entanglement. How do anesthetics work, even inert gases like xenon that don't seem to react with anything? They don't have to. They just disrupt this delicate quantum field. In these key areas, the quantum model just offers a more elegant and complete answer.
But look, a theory is just a good story without proof. And that brings us to our final section, predictions on the edge. This isn't science fiction. This is a model grounded in real, testable, and most importantly, falsifiable experiments.
Any good scientific model has to be willing to stick its neck out, and this one really does. It offers clear, testable predictions in 3 very different areas: how anesthetics work, the role of gravity, and the influence of magnetic fields. So let's take a quick look at each one. Experiment A is just beautiful. The idea is that consciousness is this coherent, super-radiant light emission in our microtubules. So anesthetics don't block some chemical lock and key, they just throw a wrench in the quantum machinery. The prediction, then, is crystal clear. If you measure the light coming from these microtubules, it should be highly ordered, bunched together. But then you add an anesthetic, and that beautiful, ordered signal should just collapse into random, chaotic noise. You're literally watching the light of consciousness get switched off. Now, experiment B tests that cosmic clock idea directly. If gravity is what collapses the quantum state and creates our moments of experience, what happens when you turn down gravity? Well, the model predicts that in a microgravity environment, like in a drop tower or even up in orbit, quantum coherence should last significantly longer. The clock would literally tick slower. This would be an incredible way to directly isolate the effect of gravity from all that thermal noise.
And finally, experiment C points toward a really fascinating practical application. If our bodies are these sensitive quantum systems, could we tune them from the outside? This experiment proposes using a weak pulsed magnetic field, tuned specifically to the Earth's natural Schumann resonance. The prediction is that this tiny signal could entrain our own biological rhythms, like heart rate variability, syncing our internal quantum orchestra with an external environmental tempo.
So, when you put it all together, the theory, the biological architecture, the testable predictions, it really does force you to look at things in a new way. Biological systems aren't what we thought. They're not just passively getting pushed around by the laws of thermodynamics. No, they are the architects.
They are actively engineering their own quantum reality, creating these impossibly protected decoherence-free spaces inside of us for one single purpose: to host consciousness itself. It reframes life not as a chemical process, but as the universe's most sophisticated project in quantum engineering. And it makes you wonder, what else might our biology be capable of that we haven't even begun to imagine?